So every reserve is unique. Every reserve is special for so many reasons. One of the really interesting things about Cherry Point is that there's a really active industry in the area. There's multiple, actually. And there's these cutouts within the reserve, and there's some natural deep water channels. So it creates a variety of habitats, and there's just a lot of activity, both human and wildlife, in this area. Plus, Strait of Georgia, it's gorgeous, it's beautiful. So when we talk about kind of the future of conservation and management making decisions, those are happening more and more in the intersection of multiple groups. And so in this graphic, we're talking about the resource managers, the academic researchers who come in and maybe synthesize the data, make it available to management. And then the scientists, like whether they're community scientists or agency scientists, whoever they are. And in this instance, I'm really focusing, and in my thesis, I really focused on community scientists, because citizen science, community science, whatever we're calling it, is such a wealth of information. I don't know if I can emphasize enough just how amazing it is. We don't have unlimited resources. Agencies can be really limited. So there's data gaps, there's loss of data continuity, and community science, there's just so much out there. I participate in community science. I think that, simply by being here, you all do too. And when I'm talking about Cherry Point and my thesis in particular, there's this group of volunteers that go out and are collecting data specific to Cherry Point. And it's so incredible to me, because there are so many community science networks out there, and this is separate from that. This is its own thing that was created for Cherry Point, and it's based off other things, absolutely. But just this, this data that's so specific to this area that the Aquatic Reserves program is trying to manage, it's just, thank you to everyone who's ever been involved. Shout out to Resources, who is the steward of that data and sponsor. Through working with this data more, I gained a greater and greater appreciation for the data set and the people who've been involved with it. So obviously we have the Aquatic Reserves program as our resource management group. And then I came in as this academic researcher wanting to use this data, make it accessible to management decisions, and write my thesis in this intersectional space that I truly see as the future of marine conservation, is happening when all of these groups can come together, contribute together, talk together, and make things happen. Oh, we have an older version of my presentation here. I'm not going to go too much into the Aquatic Reserves program or myself. These are placeholders. I'll leave this here and you can look at this one word, because I do want to share that personally, I came in and I have a wildlife background. So that's seabirds, which is why I used this data set, marine mammals as well, fisheries. And then I came in, and DNR is a habitat agency. It's a land management agency. And so I came in going, okay, I've learned all about these critters, but now I'm trying to conserve land. How does that meld together? And this thesis really kind of encapsulates that journey that I went on of, okay, how do we use wildlife to inform habitat management? How can we look at seabirds and have that be meaningful to conserving the habitats, the marine systems? And we'll get into that more, but it just, it was this incredible journey that I went on in terms of my own science and how I want to pursue my own career. And then also, my thesis work, and it really created a foundation that I hope to take moving forward personally with, okay, I can still study seabirds, I can still study wildlife, and then I can apply that data to larger conservation discussions. And that's just so cool. So that's my personal takeaway from this whole thing. We'll come back to it a little bit as well. But let's talk about the science and the scientists. I was able to join in March to go out with this group of volunteers. And it was so fun to join this group of incredibly competent birders, just so accomplished, and be a bird nerd amongst you all. And you all are, this is a self-organized group, largely self-organized, and that's just, I underlined it already, but it's worth pointing out again just how incredible this effort is. As of April, this group had completed 500 surveys, totaling over 150 survey hours and counting more than 37,000 birds. Talking a little bit, just very briefly, about kind of the methods. So we have on the left a map. The green is Cherry Point Aquatic Reserve. Those yellow dots are the 3 survey locations, and these are each visited once per month. And then the blue are the survey areas. So when I went out and joined, I was able to estimate kind of maximum survey distance, barriers to visualization, and from that I could calculate these survey areas. So these are winter bird surveys. They're happening September through May of every year, once a month. And when these teams go out, there's typically 6+ individuals. I know there's been some variation in that. And on the right, we have a diagram of kind of what this looks like. So let's say everyone comes up to Gulf Road. We have 2 teams. Each team has a spotter, counter, and recorder. They identify a spot that's kind of in the middle of their survey area, and then each of those teams surveys half of that survey area. So then what they're doing is they're counting the birds that are present. And what I did is I used those counts and used these survey areas to calculate density. So when we're talking about birds in Washington, Salish Sea, the literature, the way that we look at change over time is using bird density, because you can tell each of these areas is a little bit different. Each of the survey areas is slightly changeable. So we're looking at density of seabirds from this count data that was collected by our amazing volunteer group. This graph just shows a little bit about the survey effort. On the top is time and hours by season, which is down here on the bottom. So I mentioned these are winter bird surveys happening September through May. Surveys began in May of 2013. So we only have this one little bar here in that 2012-2013 season. When I was doing my analyses, working on my thesis, I had to do everything before the 21 to 22 season was done. So that's why you're seeing a few of these months of data missing. So I do want to put the caveat on a lot of these analyses that they need to be updated with the most recent data. And that's kind of the point of this project, was to lay this groundwork so these analyses can continue to be made as more data is collected. So we can see 2016, 2017, there were the most hours spent on survey that season. And down on the bottom, we can look at how many birds were surveyed by season. So the 2015, 2016 season actually had the most birds counted. This, as Erica mentioned, will be recorded, so I don't have a huge amount of time to go into each of the charts. I'll explain them a little bit, but you will have access to these, and I can provide them as well if people want to look at them more. So why seabirds? I keep underlying how amazing this effort is and how much work has gone into it. And why does that matter? Why is that important? Well, seabirds are ecosystem indicators, and an indicator is something that's visible and measurable that reflects the underlying system. So systems, ecosystems, incredibly complex. Marine ecosystems in particular are just interconnected. How do you measure that? You can't. What you do is you identify indicators. You identify something that is measurable, that's countable, and you use that to reflect the underlying system. So an indicator's presence and numbers can reflect the health of a marine system. Seabirds' presence and numbers at Cherry Point can reflect the health of the Cherry Point marine systems. So that's why birds, that's why these counts are important, not just at Cherry Point, but anywhere that they are completed. It's just that with this thesis, I really focused on the Cherry Point data set and what it means for Cherry Point Aquatic Reserve. When it comes to selecting indicators, not all indicators are created the same. And in fact, the Puget Sound Partnership, larger agencies looking at the whole of the Salish Sea, use multiple species. Birds are just one type of indicator. And even within birds, certain species are better than others. And so the 3 main things that come into play are, the first is data availability. So this isn't just, okay, we went out there and we looked for the bird, but the bird was there so we could collect data on it. So for instance, across the Salish Sea, marbled murrelet is an endangered alcid, and it is used as a specific indicator species. Well, at Cherry Point, those haven't really been seen. So while they're being surveyed for, while they're being looked for, there isn't data on them because they're not there. So they wouldn't be a valuable indicator at Cherry Point. We also want these species to be reliant on the management area. This is a small, Cherry Point is a relatively small area within the larger Salish Sea. These are winter bird surveys, so these are highly mobile species. They're not reproducing, they're coming through looking for food. So we want these to be species that, have some tie to Cherry Point, are seen at Cherry Point, and, really what we're looking for is birds that are choosing to come to Cherry Point or not choosing to come to Cherry Point based off prey availability. And we want them to occupy different spaces within the system. And so we don't need a lot of cookie cutters. We want different species that are reflecting different habitat types or different prey sources, and that together they can give us information. There are currently 29 species being surveyed for at Cherry Point. So these are census surveys, and that means when the observers go out, they're counting all the birds that are present on the water that are on this list. So there might be other species there, but they're not on this list, so they don't get counted. So it's just the species that are here that are being counted. Sometimes there's extra notes. Again, very accomplished birders wanting to note everything. It's always appreciated. But when it comes to the data that I analyzed, there's these 29 species that are the focus. And if they're on the list, then all of the ones that are present at the site that day should be counted. And this graph, there's a lot of information here, but we have our 4-letter species codes on the left. We have our seasons up across the top and months on the bottom. And you can see, again, May of 2013, that's why this one season, there's only this one column of data, is because that's when the surveys began. And we're missing those last few months of the 21 to 22 season. The dark gray means that that survey, that species is now being surveyed for, but was not at that time. So it started when this effort started, there were only several species being surveyed for, and that has since expanded. The latest expansion was in December of 2016, when that incorporated more species as well as kind of groups. So, let's say there's a whole flock of cormorants out on the water, and for whatever reason, they're really far away, there's backlighting, simply can't tell if they're pelagic or brants. As of December 2016, they could be recorded as unidentified cormorant. And I'm bringing that up because that plays a lot into how I could analyze this data. Individual species could be looked at, trends in individual species could be looked at from when they started, but anytime I tried to group the data, most of that analysis had to begin in the 2017-2018 season. And birders, we can go into that more next week when we dive into this. But I'm setting this up because when I talk more about some of these analyses, we're talking about only 5 seasons. And birds are upper trophic level critters. They are long-lived. They're highly mobile, as I mentioned. So it takes a long time for these trends to become visible. If there's a blue dot, it means, or a blue square, that means that that species was seen at one of the 3 sites on that day. If it's pink, red, orange, whatever that shows up on your screen, that means that it was seen at none of those sites. So coming back to that marbled murrelet that I talked about earlier, that's all the way down here at the bottom. So this is showing, it looks like we saw marbled murrelets were seen twice. But for the rest of the surveys, they just were not present in any of the 3 sites. One way to group these species is by their feeding guild, so their main prey source. So of these 29 species, the majority of them are piscivores, are fish eaters. So this includes the elsids, cormorants, mergansers, loons. The next most represented group are the benthivores. These are the bottom feeders. So they feed on clams, crustaceans, polychaete worms down in that kind of benthic bottom environment. This is a lot of the diving ducks, including Skoders. There's a few herbivores, mainly geese, and maybe a couple ducks, and then there's a couple omnivores. So we had these 29 species, and I would have loved to analyze them all, even the little marbled murrelet that was only seen twice, but I simply did not have time. I had to limit myself somehow. And so when selecting indicators, I decided to focus on, okay, I really want the species that were seen a lot and in high numbers. And so one way to measure that is by encounter rate. So this is, again, we have our species on the y-axis, and we have our encounter rate on the x. And I decided to really just further delve into those species that were encountered in 50% of the surveys or more. That would be surf Skoder, common loon, horned grebe, pelagic cormorant, and bufflehead. I was also interested in birds that maybe were seen in higher densities, even if they weren't seen as often. So again, we have our species on the Y, and this time we have density in birds per square kilometer on the X. And the dotted vertical line is the overall average. This was about 1.1, 1.2 birds per square kilometer. This is count data. This is really heavily zero skewed data. So most of the time, these birds were in low densities. This was one way I could think about, okay, maybe which ones were seen in higher densities sometimes. So my cutoff was at 1.5 birds per square kilometer. Obviously, there's no such thing as a healthy half bird, but that rounds up to 2. I needed to cut myself off somewhere. So that's a brant, surf skoder, western grebe, and horned grebe. So there's a little bit of overlap between those 2 lists, but essentially my analyses and my thesis were really deep dives into surf skoder, bufflehead, pelagic cormorant, horned grebe, western grebe, brant, and common loon. And I had 2 main questions. Those are on the right of the screen. Was there a change in density over time? And which seasons and months had the highest seabird densities? So for these 7 species that were seen the most often, were seen in the highest densities, I also looked at overall seabird density, and then the species grouped by their feeding guild. So that's the piscivore, benthivore, omnivore. And from that, I was able to identify certain species and species groups that might make the best indicators. And that's not to say only collect data on these things. We want as much data as possible, almost always. But, we're talking about capacity. We're talking about time. For future analyses, these are the species, the groups that I really recommend. If someone had time to only analyze a few, these would be the ones to do. These are the ones that are most likely to give the most valuable feedback on cherry point habitats. So the first one is surf skoder. And what I found is that surf skoders have been declining since 2013 based off this data collected at the Cherry Point Reach. Regionally, they've been declining across the Salish Sea. Some of the first surveys that were completed on seabirds were in the late 1970s. And there's been a fair amount of research comparing to those baselines. And Cherry Point, as some of you I'm sure are aware, had a historically massive herring population that began to critically decline in the 1970s. Surf skoder are benthivores. They feed, one of their big things that they feed on is herring spawn. They have enormous aggregate response to herring spawn. So as the Cherry Point herring have declined, there's been associated decrease in surf skoder. And we're continuing to see that since 2013. There's a possible redistribution of surf skoder up in Canada in particular. There's been some places that it appears that surf skoder numbers might be increasing, actually. And so that is one of the ways that I can illustrate that, this isn't, bringing this discussion not to, oh no, what's happening with the birds? Where are the birds going? It's, oh no, what's happening with the habitat? The birds are fine. They're going somewhere else. They're going to find their food somewhere else. They're choosing to migrate somewhere else. But the habitat is no longer attracting surf skoders the way it used to. And I mean, obviously since the 1970s, it's not, but even since 2013, surf skoders it seems to be choosing to go elsewhere. So what's going on? Why might that be? Birds are great indicators for yay or oh no, but they're not so good for the why, the what, the mechanisms going on behind. So they can indicate, they can point to something. And then what it's on the rest of us is to figure out, okay, why is this happening? So it opens up so many avenues for future inquiry and points us in the right direction. I mentioned that surf skoders are benthivores. Benthivores in general, that whole feeding guild is a really good one to keep an eye on. I mentioned how these grouped species groups, I could only really look at 5 seasons of data. So there's been no significant change in benthivore density since the 2017-2018 season. Most benthivores are migratory, which means that May and September have lower densities. So September is when birds are first entering the area. There's not as many here. May is when they're leaving the area again. Regionally, benthivores have been declining across the Salish Sea. Interestingly, they have not been on the coast. So, part of the reason to keep an eye on benthivores, not only is DNR a habitat agency, and the benthic habitats are, one of the things that we actually have more control over, that, we're really focused on, is we want to know what's going on with the benthic habitats. But also that there's something going on in the Salish Sea. Is it also happening at Cherry Point? I also suggest continuing to monitor piscivores. Again, no significant change. It's only been 5 seasons. Didn't really expect to see any. But regionally, Piscivores that are forage fish specialists have been in particular decline. So there's a lot of fish species in the water. Forage fish, the ones that should come to mind are surf smelt, sand lance, herring. Those have been declining across the Salish Sea. There's been a corresponding decrease in forage fish specialized seabirds. And we've been seeing community shifts away from some of those diving birds, those forage fish specialists, and towards piscivores that have a more diverse diet. One example would be pelagic cormorant. So pelagic cormorant are fish eating, but they eat a wide variety of fish species. And according to the Cherry Point data, they've actually been increasing in density since 2014. And this is one of the few resident birds that showed up in any sort of number in this data. Most of these are winter migrants. Pelagic cormorant are residents, which means they breed here in Salish Sea, in the Cherry Point Reach. They're here in greater numbers over the summer when they're breeding, and then winters they disperse a little bit more to forage. So unlike some of these other species, we're seeing different monthly trends with pelagic cormorant. They also associate really heavily with anthropogenic structures, which is why I pointed out those cutouts for industrial piers within Cherry Point. A future area of inquiry would be, okay, are there pelagic cormorant nesting on these piers? How many are there? You know, what's going on? What does that relationship look like? Regionally, there's been kind of conflicting reports. So since the 1970s, there's been declines in pelagic cormorant, according to some of the literature, but there's also possible increasing winter densities across the Salish Sea more recently. So this increase that we're seeing at Cherry Point might be on trend with the larger area. You know, there's just a lot going on with the species that keeping track of it, putting a little more focus on it can really be an interesting and telling thing about the Cherry Point habitats. These graphs are for pelagic cormorant. On the top, we have, these are violin charts. On the top, we have density by season. So a violin plot, the wider the shape, the more likely that count was to be found in the data, or that density was to be found in the data. So the higher probability of seeing that value. And these are really kind of fat at the base sort of shapes, because this is zero skewed data. This is count data. So most often there was either no pelagic cormorant or maybe only one or two individuals. You know, most often there were lower numbers, especially in some of these earlier seasons. Within the violin shape, that darker dash is the mean density for each season. And then that box is the upper and lower quartile. And so this is showing, you know, that we did see a significant increase in pelagic cormorant density across the seasons. Down on the bottom is by month. And this is showing that kind of opposite. I don't know if you can see my cursor, but for migratory species, we kind of expect that bell curve in a way. You know, they're coming into the area, they're here in the winter, and then they leave. We're seeing the opposite for pelagic cormorant. These are our resident species, right? So they're more here, they're breeding here in the summer, and then they're kind of leaving the area in the winter and coming back. The final indicator group, I would say, that I would suggest would be a forage fish specialist. I mentioned how forage fish specialists have been in particular decline across the Salish Sea. Well, there's a lot of loons seen at Cherry Point. There's 3 loon species that are commonly seen in the area. That's the common loon, Pacific loon, and red-throated loon. I am actually not entirely sure if it would be best to focus on a single species or loons as a whole. I'm sharing with you some analyses I did on loons as a whole. But I think that that's again, a direction that can be taken in the future if a single species wants to be dialed in on, you know, kind of looking at the data, seeing if any trends pop. But for this, we're talking about just loons in general. And since 2017, again, this is a grouped, you know, this is a genus level group. So I could only look since the 2017-2018 season. Since that season, there's actually been an increase in overall loon density, which is opposite of the regional trends, which have seen loons declining across the Salish Sea. So that might mean that, you know, that's an odd blip. Maybe that means that Cherry Point habitats are providing something to loons that larger Salish Sea habitats are not. That could be a really good thing. So I absolutely recommend keeping an eye on this, keeping an eye on loons, and seeing how this data develops as more seasons of data are able to be added. This graph shows loon density across seasons. So this is not a violin plot. This is just like a point and whisker plot. So each of these dots is the mean for that season, and the whiskers are the standard deviation truncated at 0. And this is showing all across all seasons of this effort, because this illustrates not just the data, but also how the data changes as the methods have changed. So these first two seasons, or the first three seasons over here on the left, the 2012-2013 to 2014-2015 seasons, only common loon were being counted. So no other loon species, they might have been there, but they weren't being recorded. It was only common loon. And common loon have been seen frequently and in high numbers at Cherry Point. And that plays out in the data. You can see that these means are higher than other years. 2014-2015 had immense variation. But when only one species, and a species that was chosen because it's seen a lot, that has artificially biased these means to be higher. So if I was just looking at common loon, I could include this data, but when looking at all loons, I have to exclude it. The 2015-2016 and 2016-2017 seasons, all three species were being recorded, but there was not yet a genus level group. So if there was a loon that could not be identified to species, then it wasn't recorded. So not all loons were recorded, only loons that could be identified to species. And so it wasn't until the 2017-2018 season that there was a full season where all loons at Cherry Point were being recorded, whether they could be identified or not. So this final 5 seasons, the ones that I used in my analysis, and this is where we are seeing an increase in overall loon density. And this is something that we can also go into deeper dive on next week for birders here who are, this might be raising some questions, and I'd love to discuss this more next week if we don't have time to get to it today. So looking forward, I think that any good research opens up more questions than often it answers. But also that's kind of been the point of this work, was to set this framework, to set this stage for future inquiry. I could make this data accessible. I could create a framework to bring it into the Aquatic Reserves program, with the idea that now people can use it. Now people can explore relationships. Now people have certain species to focus on, certain directions to go in. I can point people in future directions for where they can go with this data and what it can tell us about Cherry Point. These indicators can also be used to track progress towards management goals. So each Aquatic Reserves has a management plan with management goals identified within it. They often have something to do with certain species and conservation of habitats and restoring species numbers. Birds can help with that. By tracking the birds, we can have an idea of, okay, are we seeing positive trends in habitat? What's going on with the prey species? We can refer to this bird data for permit applications and management decisions. When are the birds here? What are they doing? What is disturbing to them even? And that brings us into how this data can serve as a baseline and reference for anthropogenic disturbances. So that's using this data and comparing it to vessel traffic. And that's also even maybe making, and again, we'll talk about this next week, updating the methods so that it's quantifying the amount of shoreline disturbance. So currently there's notes being taken on how many people are walking the shore. What if we could turn that into a number? What if we could say that's high, medium, low, moderate, whatever it is, disturbance, and then we can compare that to the number of birds present on that day. So there's so many ways that this data can be used in future, and my thesis, my work has kind of set the stage for that, and I'm very excited about it. So how can the small data set focusing on a specific area collected by community scientists inform conservation and restoration of marine ecosystems? I hope that after all of this information that I've thrown at you, you'll have some inkling to the answer for that. But it can really help in so many ways, and that's from really specific to this project. This data can now inform some of these management decisions. It's now a part of the conversations that are going around on Cherry Point management, and then other reserve management. This is Fidalgo Bay bird data. A natural step would be to apply some of these same things I did to Fidalgo Bay. How about some of our other data sets? We talked about iNaturalist data. What can we do with that? So I think that this is the direction of conservation discussions, is using this kind of data. And I hope that my work is something that can help the Aquatic Reserves program, like be the future of the Aquatic Reserves program as they take on some of those discussions and start integrating some of this data. So thank you all for being here. I think that brings me to the end. Yep. Thank you all. I want to acknowledge you all for being here, as well as the Cherry Point Birders, resources, the folks at Evergreen, Aquatic Reserves program staff. And if there's time, I'd